So how's everyone doing today? Hopefully you're doing well. Today we're going to be talking about isotopes. That's going to be our main focus. But a couple of things that are going to help you through this lecture today, ladies and gentlemen, is that I suggest that you have some notes out. So you're probably going to want to be taking some notes, right? You're going to want to take some notes. You're going to want to have out your periodic table. Okay, this is the periodic table over here. You can have a digital copy, or you can have your regular copy. And then also you're going to want to have a calculator. Calculator. Okay, and so I just have a calculator right here that I'll use. I put a calculator into your resources that are on Canvas if you do need a calculator. So, but before we do start our isotope lesson for today, what we want to do is let's start off with our little warm-up. So last class, we talked about the atom, and we talked about the 3 subatomic particles that the atom is made up of. So the atom is made up of 3 subatomic particles. And do you guys remember the names of those 3 subatomic particles? Good, the protons, the neutrons, and the electrons. So the protons, ladies and gentlemen, are located in the center of the atom. Okay, those are the protons, and the symbol for the proton was P with a little plus on it. All right, and also located in the center of the atom were the neutrons. Okay, and the name neutron has the word neutral in it, and so the charge and symbol of the neutron had no charge, so it was an N with this little 0 up there to show no charge. The P, the protons, was a proton with a little P symbol as well. And then the last part, the subatomic particle, was an electron. The electrons, they go around the outside of an atom, and the symbol of an electron was an E with a little minus on it. So the protons, they have a charge of +1. Electrons have a charge of -1. And neutrons have no charge. So that was a little review of what we did last class. Something else that we talked about last class, let's see if I can adjust this screen. No. Something else that we talked about last class was the number of protons equaled what the element was. So if you knew the number of protons, then you know what element that we're talking about. Because each element has a specific number of protons. For example, boron has 5 protons. Copper has 29 protons. Nitrogen has 7 protons. And that's what that little number is at the very top of the screen. It's the number of protons. So if you had an element with a certain amount of protons and you knew that number, then you know what element that we're going to be talking about. So as we just said, so the number of protons will equal the element. So now let's take a look. Let's take a look at this one here. It says, which element has 16 protons? Well, the first thing we want to do is take a look at our periodic table, which is right over here. And we want to say, well, where is element number 16? Which element has 16 protons? If we take a look, we can see that the atomic number up here is the number of protons. So So, oops, the number of protons equals the element. Now, so which element has 16 protons? So you can see sulfur has 16 protons. So that would be S or sulfur. All right. So let's take a look at the next one here. Clear that out. So now the question is, how many protons does copper have? How many protons does copper have? So what do we have to do? Well, we're kind of working backwards this way. So now what we have to do is we have to go find copper. So let's go find copper. We take our periodic table. We're going to look all the way through, and it just so happens that copper is right here. So this is copper, this element. And so how many protons does copper have? Well, this number right here, also known as the atomic number. So the atomic number of the element equals the number of protons. So this atomic number is 29, which means that copper has 29 protons. Okay, so this is a review of what we did last time as well. So let's just take a quick look. All right. So now we're going to be talking about isotopes. Now, isotopes are, hold on one second. So what is an isotope? An isotope is a different form of an element. So there are lots of different elements. So all of these over here on our periodic table, these are all elements. So elements would be something like maybe sulfur would be an element, S. Bromine might be an element number 35, right? Something over here, what do we got? Something down right here, xenon, all right? So xenon, element number 54. Those are all elements, but there are different forms of these elements, which we're going to talk about right now. So my analogy that I'm going to give you would be soda. So let's just do an analogy. So our analogy, oops, I don't think I like that. Oh boy, oh geez, let's stop that right now. There we go, let's try this again. Hopefully, there we go. So our analogy is going to be different types of soda. So when we're working with soda, we have soda, so we have Coke or Coca-Cola, and then we have something like Sprite. Now, we have different isotopes of Coke or different isotopes of Sprite, or another way to say it is we have different types. So some different types of Coke might be Diet Coke. So we have Diet Coke. And then we would have Coke Zero. And then we would have the Mexican Coke, which I think is the best Coke because it comes with cane sugar and they sell it in the bottles. Buy that at Costco. It's really a good Coke. Coca-Cola, sorry. And then you have Cherry Coke. So all of these are different types of Coca-Cola. All right, but they're all Coca-Cola, they're all Coke. Sprite, you'd have the same thing. You would have Diet Sprite, you would have Cherry Sprite, and these are all different types of Sprite. They're still Sprite, but they're just different types. Kind of like we have elements, and there's different forms of those elements. These are different forms of soda. So this is an analogy that I would use just to kind of give you an idea. So let's actually take a look at elements, and we'll look at oxygen. So let's take a look at oxygen. So oxygen has different types of isotopes. So you have oxygen, and we have oxygen 16. It's one type of oxygen. And then we have oxygen 17, and we have oxygen 15. Now, all of these are oxygen, but they're different isotopes. Just like the Coca-Cola, you had different types of Coca-Cola. We have different types of oxygen, and those different types of oxygen are called isotopes. Now, something that all of these have in common is that oxygen has 8 protons. So the number of protons in this oxygen is 8. The number of protons in this oxygen is 8. The number of protons in this oxygen is 8. But they have different isotopes. They have these different numbers on the end, which we're going to talk about just a little bit and just talk about in a minute. So isotopes have the same number of protons, but they have different numbers of neutrons. And that's the difference between these. So all of these will have 8 protons, but the number of neutrons is going to vary depending on the type. So just like the Coca-Cola, they're the same, but they're kind of different. Now, isotopes can affect the way that atoms react. So if there's a, well, let's just do an example here. So we have uranium-238. Let me clear the screen. So we have uranium-238, right? And we have uranium-235. Now, uranium-238 is very stable. Uranium-235 is used for nuclear fuel, like in a nuclear reactor where we generate electricity or energy. So uranium-238, you can find that in rocks. You can find that everywhere. Stable means that it's not going to change. It's not going to react very easily. It's just, it is what it is. It's kind of like a piece of iron or a piece of aluminum. It's uranium and it's 238. But this uranium, which is used for nuclear fuel, is not very stable. So this one we can find in rocks. This one here, we have to make it. So humans have to make this uranium-235 by changing uranium-238. So there's difference. So let's take a look on the periodic table at uranium. So let's go take a quick look at uranium on the periodic table. We're going to have to look all over the place. So where are we going to look? Uranium. I think it's a U. It's a U. Are we going to see it? Uh-oh. We might have to move a little bit. Let's take a look. Ah, here it is down here. So uranium is right down here at the bottom. It's element number 92. You can see it right there. So element number 92. So uranium has 92 protons. So the difference between uranium-238 versus uranium-235, two different isotopes, would be the number of neutrons. So what do they have in common? So in common is the protons, which equals 92. And the difference between these, the difference is going to be the number of neutrons. So how do we find out that number of neutrons? Well, there's a formula here that says the mass number, the mass, which is how heavy these elements are, will equal the number of protons plus the number of neutrons. All right? And when we talk about, oh, what do you mean by the number of protons, number of neutrons? I'll leave that on the screen right there. So when we looked up here before, and we had the protons and neutrons in the center of this atom, we were saying this protons and the neutrons right here make up the mass of the element. So let's take a quick look up here. So the mass number is the number of protons plus the number of neutrons. So how many protons does how many protons does uranium have? Uranium has 92 protons. So the number of protons is 92. How many neutrons does this have? We don't know. Well, what's the mass number? Well, the mass number is this right here. So this is the mass number. So the mass of uranium-238 is 238. The mass of uranium-235 is 235. And so the mass equals the number of protons plus the number of neutrons. So let's find out how many neutrons we have. Well, the mass equals 238. So the mass number equals 92 plus x, which I'll just leave as the symbol for neutrons. So let's take out our calculator. Let's subtract 92 from both sides of this equation minus 92. So let's take this out really fast. Let's take out our calculator and let's go. What are we going to do? 238, 238 minus 92 equals 146. So we must have 146 neutrons. So we have 146 equals the number of neutrons. So this element has 146 neutrons. So why don't you pause the video and you figure out how many neutrons does uranium-235 have? Why don't you work that out? Okay, good. So now let's take a look. Well, the number of protons plus the number of neutrons equals the mass. The mass of uranium equals 235. That's going to equal the number of protons, and for uranium, uranium still has 92 protons. So 92 plus something equals 235. So let's go minus 92. Minus 92. We'll take it off of both sides. Go get our calculator up here at the top. Come over here. So it's going to be 238 minus, 235. 235 minus 92 equals 143. So in this case, we have 143 equals the number of neutrons for uranium-235. Right. So let's do another example. So the next example we have is magnesium-26. So magnesium-26, we need to find the number of protons and the number of neutrons. So, and then we're going to find the symbol. So this number here is the mass number. We need to find out the number of protons. So let's go to our periodic table. We're going to go find magnesium. We're going to look all the way through for magnesium, and magnesium is going to be right there. So magnesium is element number 12. All right. And the atomic number 12 means magnesium has 12 protons. Well, how many neutrons do we have? Well, that's going to be 26 equals, because the mass number equals the number of protons, plus that. So let's take our calculators out and go 26 minus 12, which equals 14. So the number of neutrons we have is 14. Now we can always double check our work, because 14 plus 12, the protons plus the neutrons, equals the mass number. Now what would the symbol be? Well, the symbol is going to look like this. So the symbol for magnesium is Mg. So we'll put Mg, all right? And then we're going to put a 26 right up here in the upper left-hand corner. And so this is going to be the isotope symbol for magnesium. Magnesium 26. Okay, there it is. All right, so let's do the next one. The next one is Ne, right, with a little 19 on it. So let's go find Ne, and we're going to look on our periodic table. Let's go find it somewhere. Where is it? And it's element number 10 right here. All right. So we have element number 10 right here is neon. It's over on the right-hand side. And so we want to find out how many protons and neutrons it has. So if you want, you can stop the video and work this out yourself. So, okay, first thing we do is we'd say how many protons do we have? We have 10 protons. And the number of protons plus the number of neutrons equals the mass. Well, what's the mass in this case? The mass in this case equals 19. So that number is the mass. And that's going to equal the protons plus the neutrons, which is going to be 10 plus some number. And you guys can probably do this in your head. That's going to equal 9. Now, we're going to look now and say, well, what's the isotope name? The isotope name is going to look like this. All right? So we're working with neon, and it has a mass of 19. So if we use that as our guide, then it would be neon with a dash 19. And that would be how we write that out. So let's work the next one out. So the next one says, give the isotope name and symbol. Give the isotope name and symbol for an atom with 82 protons and 126 neutrons. So now we're going to have to work this out and say, well, how can I solve this? I want to give the symbol and the name. First thing I want to do is find 82, the atom with 82, and here it is right here. There's the 82. So it looks like we're working with something called lead. So the symbol for this one, we're going to be working with Pb or lead, but we need to find out the mass, and the mass is going to be the protons plus the neutrons is going to equal the mass. And we're going to need to have the mass in order to solve it. So we have 82 protons plus 126 neutrons equals, let's go get our calculator really fast. All right, and what do we got? We're going to have 126 plus 82 equals 208. So we know that the mass equals 208. So for this one, the symbol is going to be Pb with a 208 up there, because remember, that little number up there is the mass. And now what would be the name? The name would be lead 82, which means we're working with lead that has a mass of 82. Whoa, sorry. Oh yeah, rewind that, kids. Let's get rid of that. We're gonna leave no evidence of this at all. Sorry, I got ahead of myself. This is gonna be a law called lead 208. Thank you very much. So that's called lead 208. All right, so let's take a look at the next one here. Another example. Now we want to draw a picture of lithium-5 atom. We want to label the protons, neutrons, and the electrons. So first thing we want to do is want to say, okay, I want to have protons, I want to have neutrons, and I want to have electrons. So we're working with lithium. So let's go find lithium on the periodic table. All right, so where's lithium on the periodic table? Just so happens that lithium is element number 3. So we know that it's lithium-5. What does that 5 mean again? That's right, it means the mass. So lithium has a mass of 5, and we know it has 3 protons. So you'd sit there and say, well, the mass equals 5, right? And it's the protons plus the neutrons. I did not do a very good job drawing that right there. Okay, I'm going to hold you to a high level, so I'm going to put myself on a high level. It should be up in the upper right-hand corner. So the protons equals 3. So how many neutrons do we have? We must have 2 neutrons. So at this juncture, we've solved everything we need to solve. Now we can draw this. We know the neutrons, the protons. Whoa, do we know the electrons yet? Yes, because this is a neutral atom, and we talked last class about a neutral atom. A neutral atom has protons equal to the number of electrons. Okay, so in any neutral atom, the protons equal the electrons, which means if you have 3 protons, you have 3 electrons. So to draw this, We have to draw protons. So 3 protons and 2 neutrons. And then going around the outside, we have 3 electrons. And in theory, this would be our atom. Okay, so that would be drawing a picture. Now, all of this is going to be on your handout coming up. So let's take our last little tidbit and we're going to be wrapping it up. So let's complete the table below. And we're going to complete the table below by filling this up, which we should be able to do. So first off, we're working with potassium 38 and we're working with potassium 40. And we want to know the number of protons, neutrons, electrons, and the symbol. So how would we do that? Well, how much protons, or how many protons, excuse me, does potassium have? Well, we have to look all over the periodic table. And we're going to be looking right here at potassium. How many protons does potassium have? Potassium has 19 protons. How many electrons does a neutral atom have? Neutral atom has how many electrons? Same number as protons. That's an easy one. All right. So now what we have to do is figure out, how do we find the number of neutrons? Remember, the protons plus the neutrons equals the mass. This number here is the mass. So what plus 19 equals 38? We'll take out our little, I can't take out my calculator right now, but we can take a look and we could say 38, right? We could say 19 plus number of neutrons equals 38. We'll find out our answer is 19. Now we can double check our work by adding the protons and neutrons together and seeing that it equals 38. How do we find the number, the potassium 40? Potassium 40 will have how many protons? Well, no matter what, potassium has 19 protons. So it's always going to have 19 protons. This is a neutral atom. You don't see any charges or anything up there. So the same number of electrons will be for the number of protons. And now we have to figure out, what do we have here for potassium 40? Let's do a quick little math problem down here. The mass equals 40, because remember, this is the mass, right? 40 equals protons, 19, plus neutrons. Take your calculator out, minus 19 from both sides, you're going to get 21. How do you double check your work? Because the number of protons and the number of neutrons should add together to give you the mass. Okay, so that's how you'll work out the table on your homework. Okay, so, whoops. So just as a reminder, I highly suggest that you are working with, oh, I don't really think you could have seen my picture this whole last amount of time. So I'll show you what we got. Sorry, I took that thing out. There we go. That's what I look like today. All right, so if you have any questions, I'm going to be working right here. Come and get me if you have questions. Please, I do highly suggest that you review your notes. I'm hoping you were taking notes when you were doing the video. Again, if you get stuck, review the video and get to where you have to go. Find out the number of protons, neutrons, electrons. Review what we have to do. But again, I'm sitting right here if you have any questions. Okay, good luck, and I will see you in a little bit.